Welcome to Two Projects. In this video, we are going to see a hybrid metaheuristic method in training artificial neural network for bankruptcy prediction. Introduction. Interest in precise forecasting is sparked by the importance of bankruptcy in financial analysis, particularly following the 1990s development of powerful artificial neural networks. Traditional statistics were replaced by machine learning. However, ANNs are good at forecasting and interpreting complexity despite their interpretability shortcomings. But extensive training and restrictions on gradient descent prompted the development of innovative metaheuristic algorithms. This project improves ANN's ability to predict bankruptcy by combining these methods. Combining metaheuristics increases the training strength and effectiveness in identifying financial distress. Objective of the project. This project uses a hybrid approach to improve bankruptcy prediction. It predicts a company's likelihood of bankruptcy by using an artificial neural network trained on historical financial data. Metaheuristic algorithms like PSO are integrated to identify and retain only significant features in order to counteract irrelevant data affecting ANN accuracy. The accuracy of predictions is improved by this integration. Results from experiments show that the ANN trained on PSO selected features are more effective than the one trained on all features. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above, and software requirements needed are Python IDE of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload bankruptcy dataset. In this module, the project begins by uploading the dataset containing information about various companies. The dataset includes features that are relevant to predicting whether a company will go bankrupt or not. The dataset is a crucial foundation for training and evaluating the prediction models. The second module is preprocessed dataset. After the dataset is uploaded, preprocessing takes place. This involves handling missing values in the dataset and ensuring the data is in a suitable format for analysis. Additionally, the dataset is typically split into training and testing sets, allowing the model's performance to be evaluated on unseen data. The third module is Run PSO algorithm. The particle swarm optimization PSO algorithm is utilized in this module. PSO is a metaheuristic optimization technique inspired by the social behavior of birds flocking or fish schooling. It is used to select relevant features from the dataset. PSO evaluates the contribution of each feature to the prediction accuracy. Features that contribute positively are selected, while irrelevant ones are discarded. This helps improve the accuracy of prediction model. The next module is train ANN on all features. In this module, an artificial neural network is trained using all available features from the dataset. ANN is a machine learning technique inspired by the human brain's neural networks. It learns the relationships between input features and the target variable bankrupt or not. The model undergoes training to adjust its internal parameters based on historical data, enabling it to make accurate predictions on new data. The next module is train ANN on PSO features. This module is similar to the previous one, but the training is carried out using only the relevant features selected by the PSO algorithm. By using a reduced set of features that are more informative, the ANN can potentially achieve higher prediction accuracy compared to using all features. The last module is comparison graph. The comparison graph module visualizes the performance comparison between the two trained ANN models. Graphs such as accuracy versus training epoch is displayed to illustrate the model's learning progress. The graph demonstrates that the ANN trained on PSO selected features outperforms the one trained on all features in terms of accuracy. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is the dataset folder in which I have bankrupt dataset. In this dataset, in the last column, I have 0 and 1 classes. 0 indicates company is not bankrupt and 1 indicates company is bankrupt. So by using this dataset, we will train ANN algorithms and then evaluate their performance. This is the model folder in which I have pickle.json and .h5 files, which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. These are Python main code files, and this is the dataset link text document in which I have a link to download the Bankrupt dataset. This is the output HTML file which will be loaded into the application later to display the performance metrics of the trained algorithms in a tabular format in the web. And this is run.bat file. Instead of executing the project through command line interface, we have created a Windows bat file to execute the project. Now double click on run.bat file. This graphical user interface will be opened. With this, we're interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Bankruptcy Dataset button. A dialog box opens. Select the dataset and click on Open. So in this graph, on x-axis I have 0 and 1, and on y-axis I have count. So in this graph, we are showing number of 0 and 1 records available in dataset. Close this graph, and in the text area we can see a confirmation that dataset is loaded, and we are displaying top 5 rows of the data, and there are 96 columns in the data. Now click on Preprocess Dataset button. So after pre-processing, we can see total records found in dataset are 1398, and there are 94 columns in the data. So this total dataset is split into train and test sets in the ratio of 80:20. So after splitting, now train set includes 10,558 records, and test set includes 2,640 records. So train set is for training the models, and test set is for evaluating the performance of the models. Now click on Run PSO Algorithm button. So here we can see total features found in the dataset before applying PSO were 94, and after applying PSO were 57. Now click on Train ANN on All Features button. So here we can see ANN with all features confusion metrics, and these diagonal boxes are the correct classifications, and these diagonal boxes are the misclassifications. Close this graph, and in the text area we can see the performance metrics of ANN with all features model. Now click on Train ANN on PSO Features button. So here we can see ANN with PSO selected features confusion metrics. So on x-axis I have predicted class, and on y-axis I have true class. So these yellow color boxes are the true classifications, the correct classifications, and these diagonal boxes, the blue color boxes, are the misclassifications, and we can see there are very few misclassifications. Close this graph, and in the text area we can see the performance metrics of ANN with PSO selected features model. Now click on Comparison Graph button. So here we are displaying the performance metrics of ANN with all features and ANN with PSO selected features models in the web. Close this, and in this graph on x-axis I have the epoch, and on y-axis I have accuracy, and we can see for every increasing epoch the accuracy of both the models is also increasing, but we can see the model ANN with PSO features is doing well when compared to ANN with all features accuracy. Close this graph, and the conclusion here is the project successfully integrated Metaheuristic algorithms with an artificial neural network to improve bankruptcy prediction accuracy. The ANN's forecasting capabilities were optimized using PSO, and the Taiwan Economic Journal dataset showed superior accuracy. This hybrid approach holds promise for more effective bankruptcy prediction, benefiting stakeholders and mitigating financial risks.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.